Okay, as I swallow the last piece of food. Seems I need to set two indexes. Fill index and the characteristic range index. Well, shall I just pass them both to the same function? Seems more efficient. Or does it not matter? Suppose it does not matter. What the? Okay, give up. Let's use its own function. Let's give it a full name also. Characteristic range index. Now this is a bit strange. Why would I pass an index as an int? You get the value here. It's size type, the underlying value, and then use it as an index. Well, the reason is that mRange counters is a multi-loop, which has no notion of special indexes. So I just have to pass an integer as conversion. I still need to set this. So I is a characteristic range index because M characteristics is a vector that uses a characteristic range index as the index type. Okay, then Danny Xmal asks, are these like exercises? Not really, no. Real life coding, solving problems as they go, not something that was solved before, at least not that I'm aware of. And I cannot continue until I fix it or solve these things. Okay. So what happens here? Before we did call initialize. Rather now we called run on the new task, which then calls initialize on the same object. And this task is not finishing, never actually. Therefore, it's since we called run, it's still running. When we get here, and now we do the following thing. I'm setting the number of running characteristic tasks equal to the size of the number of tasks. I'm not sure I'm using this still. I don't think I am. Interruption. Sorry, interruption, because I don't think I'm using this. It's being set to true here, but it didn't exist. It's not being used. It's just set to true and nobody else is using it. I might as well delete it. Okay, so I'm setting a number of running characteristic tasks and equal to this size, and they are running because we did first get here, and that runs over the same list. So this the size of that list, well, already set it here, but then it got decremented to 0. But this is the number of tasks that we started then by running them, and therefore they are still running here. Then we run over all these tasks. We tell that each task what the set fill index is and what the characteristic range index is, and then we send that a signal. And the signal is called do fill. Let me check if this is the right namespace, because characteristic range lives in the namespace vulkan pipeline. While here we are in namespace, I think even task. Yeah, we are in task. So I really have to pass the whole namespace here. Vulkan pipeline characteristic range do fill. That is a signal that we send to the characteristic range task. I can jump to it from here, which is implemented like this. So multiplex implementation is the implementation of the task. So it might be waiting for this signal, and then when we signal it, it will continue running, and it will run in this state. So the result of sending it that signal will cause us to call fill. And after calling fill, it will call characteristic range filled on the owning factory. I'm wondering now why I'm not calling update immediately after fill. Maybe I should do that. I mean, we are calling characteristic range. Oh, yeah, filled, passing the characteristic range index. It was set before. before we send the signal to this task. And then we do this. But this is the task that we just came from. Okay. I could have called update therefore in this object itself, but we also need characteristic range here. And we do not have access to mRange counters in the previous object. That's a member of the pipeline factory. So I guess this has to be done inside the pipeline factory because of the mRange counters. And therefore we must pass the characteristic range index. You can also pass maybe let's say a reference to the range counters, but yeah. Now I am worried about the thread safety of accessing mRange counters. But yeah, as long as this signal is not been sent, the parent task, which is this task, is not running. It's waiting. It's waiting for this signal. So nobody's accessing this, I think. Just the child tasks, which are only reading it. Now multiple threads reading this thing should be okay. I'm guessing that update is running. It can only be running after it read this, right? Well, it's unfortunately not how weak memory access works. By the way, I did remember what this was so special about read-write operations, atomic operations. They have a total ordering. Although I forgot if they have a total ordering like also with all sequential consistent things. I think so. I mean, obviously they have a total ordering with whatever memory location they alter, read and write to. But the ordering is also guaranteed to be to exist with yeah, more stuff, but I cannot remember anymore. Well, actually, I think it has a total ordering with all the sequential consistent atomic operations. Maybe I should go read a few of my answers on Stack Overflow to refresh my own memory about memory order. The music is stuck again. Extremely annoying. Right, so yeah, I think we're pretty safe. The signal is a locking mutex. That's a super big barrier. So that must be safe like this. Let's see what the update is doing here. Definitely not the update I was looking for. This is the one, I think. That's some nasty access to the pipeline index. Reading it and writing it multiple times. And it says here, this must be done in the same order as the characteristics are added to the factory. Oops. There goes the functionality. That doesn't work anymore. So this updates and pipeline index, right? We have a characteristic object here on which we call update, which then has the mbegin and the mRange width and the mEnd and again mbegin, and there will be semi-constants. And furthermore, we have an index that is being used, and then we update the pipeline index, where the index is the current range counter. And before this was called by the same thread that did everything else. So we were just calling this for a slowly incremented characteristic range index, I think. This one we just begin at the beginning and then every time be one larger. Okay. What type is this index? Characteristic range. Probably this one. That's a bit vague. Pipeline index. Yeah, it's a pipeline index. Guess I should start with renaming that to make it a bit more clear what that is. So, is this not the same thing? Pipeline index or becomes the pipeline index. That's just the cost of the index minus n begin. Casted to an unsigned int. Shifted by the range width times characteristic range index. Normally we would be called it started shifting immediately. Bear gave the exact correct answer. And it's a good way to identify the good things in life. If once you start with it you never stop again, then it's a good thing. For example, I used to write const before the types, so I would write just like in the compiler errors, const shader input data reference to the const on the other side. I did it for years and years. And at some point I wrote a web page about understanding const qualifier, and I came to the insight that it was kind of a special case to put it in front. It's much better and logical and more consistent if you read types right to left always. So this is a reference to a const shader input data. If the read is from this side or that side, it's just how it is. And I wasn't used to that. But okay, I just thought, you know, reason tells me, or logic tells me that it is more consistent to put it const always on the right. So I started doing that. After 2 weeks, I was used to it. Not only used to it, I would never ever want to go back. I'm convinced that anyone who's used to having const on the other side is just used to it. And once you switch, you will never go back. And for me, that is a proof that it is better. The practical IT field. The real life. I'm doing something wrong here. Do I still have the old code? Ooh, that's a bit much maybe. Okay, I didn't undo. So what I did is, what I expect is that update is being called, like it said here, in the same order as the characteristics were added to the factory. That means first with the index to that points to the characteristic as 0 and then 1, etc. Oh, it does. Sorry, it does work. Yeah. So pipeline index is 0, and the first time it is, just begins with 0. So this whole shift doesn't do anything. And then the index 0 is being put. I did do it wrong, but still. After the first call, pipe index is just equal to whatever this is for range number 0. And then the second call, the range 0 is shifted. And then the value of range 1 is added at the least significant bits. And so on. Therefore you end up with something like this. Where totally on the left side you have range 0, and then you get range 1, and then you get range 2, and so on. Now I want to get rid of this, because now we're not going to call this thing in the same order. We're not going to call it first for range 0, and then range 1, and then range 2, and then range 3, etc. It is going to call them in a random order, but I still want to end up with this. So I do redo my edits. So now this is the range index. So if we would call this with 0 and then 1 and then 2, etc., then the old code was correct. But in fact, what we need is a huge shift for range 0. Oh, we don't know that it is. We don't know the end. Or do we? We don't know the largest value. So maybe I have to reverse this. Put number 10 on the other side. Yeah, why not? Pipeline index, and okay, so we just OR it every call, we OR it and we fill in whatever range it is. So this is a 3. Then we just fill in those 4 bits, assuming a 0 value everywhere. I can just do an OR, and then the shift is calculated here. But yeah, that uses the least significant bits when the range index is 0. So then 0 comes here. Oh wait, it's oh no, it's way more difficult. I see. The width changes. The range width changes. It's not a constant. This one has 2 bits. This one is 4 bits. This one is 2 bits, 3 bits, and so on. Oh. Yeah, does it make it easy to get this value correct if you get them out of order? Unless I would change the range width into a shift, like literally the shift for that value. Guess I'll have to investigate how that worked. how that is initialized currently. And we'll range with const. Comment says calculate the number of bits needed for a hash value of all possible values in the range begin and end. Begin to end. For example, if begin is 3 and end is 11, then the following values are used. 3 is 000, 4 is 001, and so on. Hence we need a bit width of 7, which is equal to 11 minus 3 minus 1. Yeah, I don't know. I think I'll have to add a new variable and then calculate that during the initialization stage. Calculate well, let's call it the M range shift or something. Not sure that is working. Difficult. Okay, anyway, this is wrong, so I'm just going to fill a shift or something, which then doesn't compile anymore, so I'll be reminded about that. And then I need at least an accessor for the range width. I don't really have accessors yet, except these two. Oh well. So unsigned int range width. But if I'm not really using the range width all the time, then why would I store it? It's calculated as end minus begin. Aren't those stored? Those are just stored in mbegin and mend, and I don't think they'll change. These are also const. Yeah, so the whole range width probably should just be begun. And then instead of an accessor, I make something that returns whatever this is calculating here. Did you try Googling it, Heisenberg? Range width. Okay, I broke everything. I broke everything. Interesting. A pipeline index is a wrapper around size type, and I want to do an atomic operation on it here. It would be totally possible if it was a wrapper around an atomic size type, but it isn't. So suddenly we cannot do that. Now the question is, shall I make a special atomic index? Or I'm just going to use a mutex. I think a letter, right? Just use a mutex, I guess. But I don't use mutexes, I use my own library, AI thread safe. And this is not true. I have to pass the shift width, I think. I think separately even. It's not really width, just a shift. Let's call it range shift. Val asks, how long have you been doing this for? This project, almost 2 years. All the source code I'm using, 12 years. Coding in C++, 28 years. Coding in general, 46 years. I'm just going to pass, I guess, an int or something like that. Range shift. Okay, I need to convert this to an AI thread safe type. They usually use their own types, the type defs. So let's say this thing is a pipeline index type, and I'm going to pass a right axis type. We pass those by const references. Then we have the mutex, and we are going to see. I think these things have star operators also. I wouldn't know why not. No, I'm not sure. Yeah, that is something, isn't it? Now this is a characteristic range, and the pipeline index is going to be part of the pipeline factoring. So probably will be defined there. which is in the namespace task, to something like this. Now we've broken off. Okay, I'm just gonna compile and see what I have to fix to get the rest working. Okay, the first error is the pipeline index doesn't exist. That is totally correct. I just sucked it out of my thumb. So pipeline factory must have a pipeline index type. And it already had some kind of index. Pipeline factory index, is that the one? I'm not sure. It was whatever we were passing to update. I think this is .cxx. I guess I would call it update here. Here we're calling update. So yeah, what we were passing was m pipeline index. So I have to replace that one. And this one, right? Yeah, I renamed index to. Oh, that's why it is called index. It's in namespace pipeline. I renamed it to pipeline index. And now we have pipeline colon pipeline index. That's nasty. Yeah, I don't know. That's a difficult question. 2 pipelines or an index that is a bit vague. If you are not aware of what namespace you are in. I think I'm gonna go back to this one. Okay, so now what we wanted was that this becomes a pipeline index type. Which is then defined as pipeline index type is AI thread safe wrapper, a wrapper around the vulkan pipeline index, and then we need a policy AI thread safe policy. Is it not called simple? Nope. What is it called? I cannot remember. Just jump to policy, see if I can find it. I have a rewrite primitive, that's the one. Primitive. Use just a normal mutex. So now it's thread safe, as in this is a vulkan pipeline index and a mutex, standard mutex pair. And you can only access the index by first locking the mutex. Absolutely no other way to access it. So now it should know what the pipeline index type, because I added it and I pressed caps lock. But no, pipeline index type has not been declared. Just added it as well. Task pipeline factory. Did I not add it to task line? Did I not add it to pipeline factory or what? Let's look where I added it. It looks very much like pipeline. Pipeline index type. Let's add it to pipeline factory in namespace task. Task pipeline factory. It's private. Why is it private? Let's not make this private. Shouldn't make a difference though. It should complain about it being private. So I don't think this fixes anything. See, no difference. Well, I guess we didn't include a header. Pipeline factory header. That's always a problem, including a header inside another header. Something nobody likes. Might not even work. Is forward declared pipeline factory. Well, I can turn it around. If pipeline factory header includes the characteristic range header, yep, it does. So instead of defining it here, I'll just define it in characteristic range. Yeah. On the other hand, you know, still need pipeline index in, which, where is that defined? Or does it not matter? Maybe we can work with the forward declaration here. So now I have defined pipeline index type in characteristic range. Nobody knows. I removed it here. I might as well add it back then, or not. Characteristic range.h is included and defined here. What the hell? Oh, that's nonsensical, I think. I hope. Using pipeline index type. Characteristic range pipeline index type. It's in pipeline. What am I doing? Insert pipeline. Okay, what are we doing? Now I have that, but it's still not defined in wherever my error was. Okay. Oh. What is this? AI thread save.h error invalid application of a line off to incomplete type vulkan pipeline index. Right, so that's not allowed to. We have to define this thing. So I cannot forward declare it. I think the whole problem is just that I renamed it. Expected identifier before. Oh, that is typo. I left a comma there. It's just an editor. The IDE. It's just new Vim and Vim. End was not declared in the scope. That came from the constructor of that code. And the constructor had end and begin as arguments, but then we stored in the const variables here. So we should use m begin there and m end. No matching function for call to vulkan pipeline characteristic range update. Yeah, I just heavily changed that. The candidate is, let's add that too. So update now looks like update now looks like this. Yeah, we have to pass a write access type to the pipeline index and the rest, and I cannot remember that, so I just copy it and then I go back. Here, what? Back like that. Paste it here or not. What happened? Dude, next. Copy it. Back, print it. So that's my line. I'll just leave it like that, whatever. That's what we need to pass. While my pipeline index now is pipeline index type, which is defined as an AI thread safe thing. Only needs to be write log while inside this function, so I just might as well do the pipeline type write what. So that logs the mutex and then returns the write access type. Passes that to update. Oh now let me first run ctext again. Can you do F space here? No. Sometimes it switches suddenly to VI things. Pipeline type is still not highlighted. Ew. Why not? Because this pipeline index type, idiot. That's why. So part of characteristics is part of both classes, added it to both classes. So it's also in pipeline factory. It's okay, that just works. The second argument is a size type, characteristic range index as a size type. That should be that one, I guess. Yeah. Then we get the real index, or whatever, real index, some other index, God knows what. That's more like one of the multi-loop, for loop counters or loop variables. At some point you just have to stop thinking about it. This is what it was, so that's what it still is. And then we also need a range shift. We need to pass a range shift to it. Okay, I think that we have to do that like I think a new vector that is a member of the pipeline factory. Call that M range shift. Wait, a vector. It is a function of the range, so you can just pass the characteristic range index to it. Yeah, I think so. Except of course now we do not have an M range shift defined yet. I have to add that to the pipeline factory. And it is very, very much related to whatever other thing I have that takes this as an index, because we're also going to use that as an index, aka M characteristics itself. I kind of hesitate to add it to the characteristics itself, though. I don't know why. I don't feel right. Vector something, and this was called range shift. Yep, range shift. And that was just a size type, or what did it return? Oh god. Call to update here. That's an int. Okay, int. I should have jumped to characteristics. Yeah. Yep. Okay, but this says that add is initializing M characteristics, and we're going to initialize this thing somewhere else. Although I'm not sure yet where. In initialized, I guess. Let me see. I'm jumping to. Maybe it's initialized. Jump here, jump to the state. Initialized is calling initialize, yes. And then that would be a good point to calculate it. And I'm just gonna say that that's where it is initialized. putting it here. Let's put it higher. Okay, so I have to calculate the range shift as a function of the characteristic range. And then initialize that here. So we run over all the characteristic ranges, and then I equals now the index that we need, and then we can assign the range shift here, whatever that is, like that. And then the range shift is I guess I'll have to reverse them now. That is, range shift was an int, so I'm just making a range shift here, which is 0. And then we assign that, so now characteristic 0 has a range shift of 0. And then we increment this with the range shift width, which we get from here. A range, just range shift, I think it was. Nobody knows what it was called. Not width, range width. Yep. That one. It's an unsigned int. Why not make this an unsigned int? Two, then. Why not make m range shift an unsigned int storing thing then? Which means that update must take an unsigned int. At least that seems logical. And that should work for the shift. Okay, but now I did invert them, because now range 0 has the smallest range. So I'm just going to say that this is for 10, characteristic range 1.0 offset. And then this is range 0. And this is range 9, 8, 7, and so on. characteristic range index was not declared. Did you mean Vulkan pipeline? Well, I guess I did. Is there really no... Oops, what happened? Is there really no translation in YouTube chat? It's been a while since I could understand what people were saying. Using pipeline index type. Blah 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 has no member named set to 0. That's because we changed the type. Yep, I also need to have the right log here. And we need here, and you just need a read log, even though it's just a mutex, so read and write log are the same thing here. Oh, then we just have the read log type, and so I need to dereference that to get the actual value. Here's another one. This one takes the right log type, but here we have to dereference it like that. And here, I guess the read log here is also good. It's just the same thing as this. PsyJix2 says developing Vulkan engine, figure this is only halfway. You think I'm already halfway? Nah, just kidding. Just opening a window with a render context. Well, I'm a little bit further than opening windows. Yeah, no, I'm pretty far. I kind of covered everything and that is done in a tutorial. And then I went really far. So basically, you know, I looked at a tutorial and then I implemented everything they used in my own way, making it as flexible as I can think of. If you use my Vulkan engine, you're not even using Vulkan API anymore, as it were. But it compiled, by the way. Let's look at the git diff, because I made a few horrible changes. Okay, I'm gonna go over, this is also the changes I made yesterday. The idea is that my pipeline characteristic range objects And you can forget about the range because I'm not even testing them or using them yet. So just let's call it a pipeline characteristic. They do stuff inside an initialize function, and I want to be able to just stop doing whatever they're doing in the middle of the initialize and then later continue. So I just leave the function somewhere in the middle and then later I want to continue it. Kind of like the new coroutines that they have. Except I was first and yeah, I was first. I definitely was first. And I approached it in a different way. I approach this with tasks. And the only way then I can do that is by changing the initialize into a task itself. Which I then did is by, well, this initialize is part of a function, which is, sorry, part of a class, which is derived from pipeline characteristic range. So I turned my pipeline characteristic range object into a task. The task that I wrote, we'll just see this when I go over the div, will execute initialize. But we can no longer use arguments, function arguments like this, because if you leave in the middle and you come back later, then everything that you have, say, on the stack, including these things, they came from the stack somewhere, they must be object variables, so they survive leaving the function and when you come back. So that's about the first two lines. So I got rid of these two arguments. They have become now class members, class variables. So instead of passing them, we set them in the class as a member, and then I call this. Then we still have access to it. So we should see how, for example, owning window, or does it flat create info? Flat create info before was an argument that was passed, and now it's just simply a member of the class. So hence the M underscore in front of it, because it's a member of the class, of this object. Also changed it from a reference to a pointer, but well, that's not much difference there. Okay, the change here is same thing. This was an argument of the function. It is now become a member of the class. But for the rest, it's doing the same thing. And here again, for the flat create info, it's a member of the class. Same thing. This is just owning window that became a member of the class. And again, the flat create info, and again the owning window. So nothing really changed, you know. Okay, I since I made this now a task, every task has a boolean as a constructor. And if you, well, only in debug mode, if you pass through, then the task will print debug output. Yeah, about its state changes and stuff like that. And if you pass false, then it will not. That means that since this is now derived from a class, namely PipelineCharacteristicRange, and that is now a task, we have to pass this boolean. Instead of redefining the constructors, you can just do using, and then you specify the constructor of the base class, and then whatever constructor that base class has, you can now call directly and use as a base class, as a constructor for this one. So I removed the default constructor and sorry, this is default constructor, means it has no arguments. And I say just use whatever the base class is using. And here you see that in action. This is well, it's saying add the characteristic and then that type, but then this member function of Pipeline Factory, it's a template member function. You pass a type to it. It is going to create that object. So this is our task, in fact. And now, instead of just passing this, we also have to pass true if we want to debug output, and I do, and only in debug mode. So this function just takes the same arguments as the constructor of the type that you want to be created. Okay, this initialize is replaced by that one. So also this one did lose the owning window and the flat create info arguments. And I also added the constructor, which is just using the base class constructor. And then this function also did not change, except that those arguments are now named m flat create info and m owning window instead of owning window. I don't think anything else changed here. Well, of course, I don't print those arguments anymore. So just entering with only a single argument here for the function. So here owning window became m owning window, flat create info became m flat create info, and so on and so on and so weiter. This is same. Yeah, this initialize became that one without the arguments, and I added again, please use the base class constructor. And here we do not pass these arguments. I just pass the 0. The arguments are now gone. Same here. And this is for a different pipeline, so it is a test, and I'm just testing with characteristic. This is a characteristic for pipeline 0, and this is a characteristic for pipeline 1. But they are so much the same that I just call the same function, except that I pass a 0 here and a 1 here. But yeah, to test that, the type had to be different. So we use a type that ends on 0 or a type that ends on 1. Now and here you see again that same thing. In order to construct them, we have to pass an extra boolean in debug mode to get the debug output now of the fact that they are now tasks. And here is then the implementation of the task. So characteristic range has turned into a task. That means that it has states that it goes through. These are just a listing of the states so that I can print them for debug output. So this means state string implementation, and it simply returns a stringified thing. Whenever you pass this enum as a type here, then it returns it as a string. This is the real implementation. Okay, first, whenever we start a task, first initialize is being called, and then depending on whether the fill index was already set, it begins at -1, so it was not set yet. We're going to start at state initialize, otherwise we will start at state fill. And I should remove this because I changed it. We will always start running at initialize. That's the first state. which currently simply calls initialize without arguments. And then on the owning factory we call range characteristic range initialized, signifying that the initialize was returned. After calling initialize, we want to continue with this state. So I set state already at fill. And then I say, but don't run that until you get the signal do fill, or if we already had that. This break then leaves the function, of course, and then the thread is returned to the thread pool until this signal is being received. When the signal is being received, it will start running it again and enter here with this state. So the switch switches to here, and then it calls fill. And then it is the same thing. When fill returns, it calls on the owning factory, and the function characteristic range filled, and then it waits again on the next signal, on the next do fill signal. It keeps doing that forever, and the only way to stop it is by calling abort on the task. So this is a very simple beginning, initial attempt to turn it into a task, and then I can make it a lot more complicated later on once this works. Yeah, we need a few new headers. Here you see that the characteristic range that already had a reference count, and now it is derived from stateful task, so that turned it into a task which uses the same reference count, so that was easy. Condition type is this is a bit mask for our signals, so we use 1 as just a bit as a do fill signal. And just now this evening I added thread save wrapper around the pipeline index. It is being used a bit lower, I guess. Here are the two function arguments, which now have become the class variables. I'm owning window and flat create info, it's a pointer. And there are the other two, also previously function arguments, and now they are just part of a class. Before we had an m range width as a class variable, but no longer, because I didn't need it anymore. So the constructor changed because we do not need to initialize it anymore. So we're still initializing and begin and end, and the range width was calculated from that. But we might as well do that every time we call this new accessor here, or not really an accessor now. It accesses m end and m begin, I guess. And I see again that the function arguments have been removed. They are now class members. Okay, I reversed the order of these bits, because it just seemed to be more handy. And this update function became a lot more complex. Before we just had pipeline index and an index, and then I would shift the pipeline index, which is actually the output variable here, a bunch of bits, and then we would fill in the new bits. But now I no longer know in which order update is being called, because with this shift here you had to call it in the precise order for index 0 and then 1 and then 2 and so on. And I don't know anymore in which order they're being called. So instead now we can still assume that the pipeline index is 0, but I'm just ordering it with whatever masks, you know, then this one, and then these two, and then this bunch here, in whatever order they appear. For that we do need to pass a shift so that I know where to put it. And something is wrong. Yeah, this doesn't work. Actually, it does work. Yeah, it does work. The point is we do know the width in advance. The range shift has been calculated from all the width. They vary, right? This one has 6, width of 6, and this one has a width of 4, and this one even has a width of only 2. But if the width was established, or what is it? Yeah, well, established to be 2, then the value will never be larger than 3. Because, well, we just know it will never be because it uses 2 bits. And if it would be, say, 3 and it would be some area in the middle, then if we shift it, then whatever we get on the right are all zeros. And if you then do an OR, it will leave all the other bits alone. So it works. It does work. Yeah, task specific code here. I think these functions declarations were just moved from below to here or something. So this is required for the task. These are the definitions of the states that we use. And in fact I'm not using this, I'm not using this, so I definitely have to change that. I keep forgetting that kind of stuff, so let me just do that immediately. There's one other thing, right? Yeah, can do. We only have initializing fill at the moment. And this was nonsense too. And if I just do not have an initialize implementation, it's just going to start with the first state, which is the initialize, which is what I want. So that's okay. I can just delete this one. And then remove the declaration as well, initialize here. I think those were the only 2 changes that I saw so far. Okay, so now we have these functions here that set function arguments, which are now class variables. So you have to call this then in advance, and then store the actual values in the class, in the object, I mean. Same here. Same here. Yeah, that's something to for debug output, implementation that prints the name of the task and the name of the, already saw this one, the name of the states. And the multiplex implementation, already saw that one, and this I just deleted. Yes, I'm Dutch. Okay, fill had its arguments removed. And here's a constructor, which, as you can see, has this debug boolean for the printing output. Now it has become a task. Okay, also we had to pass the owning window to this characteristics, because you might have just noticed that I only pointed out 3 new functions, while we removed 4 function arguments in total. 2 arguments from one function and 2 from another function. So the 4th one is set here, along with the constructor, instead of setting it with a separate setter function. Our add was renamed to add characteristic, just to be more clear about what we are doing. No other changes here, far as I can see. Pipeline Factory, however, did get, which is also a task, did get 2 new states. And yeah, these are callbacks then from the new tasks. So when we call initialize and then initialize was finished, it did call characterize range initialize, right? Now what that does is it subtracts from an atomic counter 1, and if that was the last one, then we signal that the pipeline factory that all the child tasks are finished. All of them are called initialized, and then the pipeline factory will continue, as you'll see in a moment when I'll look at the task implementation of the pipeline factory. Same here, if all the child tasks called filled, then this function of each of them calls filled, and then if all of them are done, we send a signal to the pipeline factory to continue. And for each child task, aka the characteristic range, we also had to call update, which constructs that big bit mask. So it is right locking the pipeline index, so it's thread safe, passing that as an argument, and that then will update pipeline index with a few bits that this characteristic represents. And in order to do that, we needed to pass the characteristic range as a size type, and the current counter that belongs to that index. If it is a range, then this counter runs 0, 1, 2, 3, 4, whatever, so how big the range is. And then we have the range shift in order to know where the bits are in this big mask. Okay, this needs changes. I hope the viewers like what I'm doing now, explaining line by line my Git diff. Because you know they usually just scroll over at a high speed. So this is pretty time consuming, so kind of hope that people appreciate it or can follow it. This is no longer needed. Let me find that back. There it is. I don't think I'm even using parent anymore here. Yeah. Okay, so what we do here is just delete this line and just fill my atomic with the number of characteristic range tasks. Initialize a local variable with range shift. Call it range shift, set to 0. Then we run over all characteristic range tasks. And then the first one gets a shift of 0 and the next one gets a shift that is larger with the width of that characteristic. I did put it in a different vector, but maybe I could have just added it to the characteristic object here. I'm not sure. I mean, the width is the same for each characteristic, but now the range shift depends on on the width of the other characteristics. So if someone would use a certain characteristic together with other characteristics, then its shift changes. So I felt better to just use something more specific for this factoring and not specific to the characteristic itself. So here we call then the set flat create info, that sets the former function argument, and then we call we start the task, which then is going to call initialize, and that initialize then has access to this because we set it here as a member variable of the object, and the owning window was the other one, but the owning window was already set when we created the characteristic. So it has all the same information, and then it can do its initialization. So this run now causes it to start at the characteristic range initialize state, which then calls initialize, and after that it calls on this object, the pipeline factory, and the callback that we just saw here. Range initialized, which just simply counts until they are all finished. And then we get the signal characteristics initialized, so that you can also see here where it waits for it. It just starts all the child tasks, sets the state that it wants to continue with, and then says we want to wait until we get that signal. So we'll get the signal when all of these tasks are finished, and then it continues here. And then we just do the same thing as we did before until we get here. I mean, okay. There's a pipeline index is now made thread safe. That is wrapped together with a mutex. We have to create the right access type in order to lock that mutex, and then we can set it to 0. Note that this is a temporary, and the temporary will be destructed after the semicolon, aka after the set to 0 returns. So this locks, calls a function, and then unlocks. Number of running characteristic tasks again set here, and again we do not pass these arguments, but we just set them. So the mRange count is being set, and the flat create info was already set. We do not have to do that again. It was set previously. We do, however, need to pass this I. That's a loop variable here. So that's being set as well as a object variable now, and then we send it this signal do fill, causing this task to continue running, because well, it never stopped. It just sent the signal to the parent here to continue running, but itself then started waiting. So now we send all the characteristic tasks the do fill signal. They all start running again. Call fill, and then call that that filled callback. And when they after this we just wait again, and then when all of them have finished, or all of them have called fill, the last one will send a signal to this task so that it continues running. That causes us to continue here. And then this is a very complex loop, a multi-loop, so a dynamic number of for loops inside each other. Nobody knows how it works anymore, but definitely we're going to get back at this point. In fact, fill is going to be called with the range counters is a wrapper around an array of basically the for loop counters. So it's a bunch of integers that goes over the whole permutation of whatever value they can take, and the fill is basically the copy of that. So while running in this multi-loop, we get every possible permutation of these range counters, which then determines where all the characteristics are in, all the characteristic ranges are in their range, which I'm not testing yet, by the way. So I'm just calling fill once and that's it. God, this is just the fact that now the pipeline index must be thread safe. So we change it from a simple variable to something that has to be read logs in order to pass this value. These are the changes to the pipeline factory. We have now more signals, an initialized signal and a filled signal. It also stores for each characteristic range the range shift, which is calculated in the initialized loop. And then we have a new variable here, number of running characteristic tasks. The pipeline index is now thread safe, so wrapped together with a mutex. 2 new states. Just a rename of the function. The 2 callback functions. And that's it. Oh, it compiles. We just tried that already. I can commit it, I think, because it's a kind of a milestone. The fact that it compiles is alone is a milestone. Let me just remove these junk files and then let's have a look. I made the changes to stateful task. Oh, just command change. Okay. Oh. There were other changes onto the documentation. Yeah. And then I can do, I guess, a git commit once everything. Look at my task. Yeah. Yep. I don't think actually it is being called like that, right? It's more like pipeline characteristic range. Git push. For everyone who likes to look at it before they go to sleep. Blah, blah. And then we run it. Crash. My guess is it crashes, but I didn't see anything wrong while looking at the diff, so I don't know. It crashes. A sec faults. Yeah, well, sec fault is not an assert, so we just have to run this in the debugger, I'm afraid, to see what the hell is going on. Unless, of course, someone saw it while I was going over to git diff. Scream in the chat like, no man, wasn't it obvious? Of course that crashed. You did this and that wrong. I only see people talk Russian. During the calculation of range shift, something is going wrong. Why? Range shift is still a value of... Oh, right. Yeah, range shift is just a vector, so it doesn't have this. I need to resize it in advance. That is a stupid error. Bleep. Huh? What? I'm still editing something. That's not good. Undo. Oh, I deleted that and committed it. Oh no. And I pushed it. Oh, horrible. Horror. Git diff. Git commit minus everything. Oops. What am I doing? Trying to edit this and then Well, I guess. Can we use an atomic there? Call me crazy, but I don't want to load it. I don't want to reload the atomic. Because I think it's going to access memory again, all the way in the RAM. Well, this is not performance critical. Took a while, but eventually I found the words. That can be relaxed, I think, because we're going to log mutex afterwards before I read it. Pretty sure that's a memory barrier. And there's all kinds of ordering going on, of course. I mean, it's just, you know, this might start a new thread. Well, it's not starting a new thread, but if it would be, then there is still the same ordering. And the same thing should happen for using a thread from the thread pool. That new thread is just going to be able to see this, even if we use relaxed. Okay, MNHO. Oh. Hello. Don't use a nick like that and then say hi, Carlo. No, I have to. I can say hi back, but I feel like I have to say hi. Hello, who loves who? No? No? Yeah, whatever. What? I cannot pronounce your name. It's not even Russian and I still cannot pronounce it. Yeah, there's someone else who has a Russian name and he says, I feel jealous about your confidence when it crashes. Thank you, yeah. I even realized that myself. I guess you get used to it. I mean, you just make changes and you get horrible compile errors or it crashes. And if you do that several times a day for a decade long, then at some point you're like, oh, okay, you know, this is gonna take 5 minutes and then it will work. So who the fuck gives a shit? Let me see what, I don't know what I just did. Oh yeah, resize. So I was just writing to index 0 of a vector that was empty. That's not allowed. The chance that it just runs is now increased from, I think it just crashes, to more than 50%, maybe even 90%, but it cannot be both because it's an estimate. What is my feeling about this? I actually think it might run now, so it's more than 50%. Let's say 80% chance that it runs. It runs, I should have said 90, I know it. So that was the only bug. Oh, well, unless of course loads of things are wrong, but my test program isn't testing it. But hey, now the fun part. Is everyone ready? Now we're going to look at the debug output. It's going to be so much fun because it's going to tell us exactly what it is doing. And then we'll see all those nice states. That's the other way around. No, let's do less minus R, troop. Yeah, that's maybe should explain what you just saw to the person that said that was cool, man. So we have a window and it's divided in two. The left part is printed by one pipeline and the other half is printed by another pipeline. And the reason that it moves is because I fake, actually it should be printing the same thing every time, but I'm using what I call frame resources. So if say you pass a uniform buffer to the, that's what I do. The corners of my triangle are defined by uniform buffers, which means a CPU can write to it and then the GPU will read it and use it in a shader. But if I change a uniform buffer, so I change the coordinate, and then I tell the GPU, okay, go draw the new triangle, then the GPU is using that buffer. It's going to read the coordinates of the triangle and then draw it. I'm not allowed to change that buffer while it is drawing it. So then does the CPU have to wait on the GPU until it is completely done drawing a frame? No, we don't want that. So what I do is for the next frame I use different shader resources. I use different uniform buffers. So I write coordinates of my triangle to some uniform buffer, and then for the next frame I write the coordinates immediately to a different uniform buffer. And in this case I have 5 frame resources, which is ridiculous. 2 should be enough. 3 is overkill already, but I have 5. So I write to 5 different uniform buffers on a row before I write to the first one again. Now if the GPU would still be busy with the first one, then I have an incredible latency, of course, because I already created 5 frames and the first frame hasn't even been drawn yet. So that's another reason that you don't want to set frame resources to 5. But let's say we normally set to 2. Anyway, what I did was I hacked some code, which is, it's really, yeah, you should not do that. But the code that switches between the frame resources alters the actual value that I write to a uniform buffer. So as a result, you see a different triangle. The top of the triangle is moved because it's a different resource. Frame resource. So the animation that you saw proves to me that we have 5 frame resources. And 2 pipelines. Okay, and uniform buffers that we can write to and that get across to the GPU. That's the actual test. actual test for this thing was that I can write a float variable to memory and then have the GPU read it. And in order to prove to myself that the GPU did read it, I'm using it as a coordinate of a triangle. That's why it is called a uniform buffer test. It's just testing that I can write floats and read them on the GPU side. Okay, now back to what I was doing here. So at some point we're going to run the pipeline factory, it's called, right? Pipeline factory. Here the pipeline factory is created. It's a constructor. Here it is actually created. Here's another pipeline factory being created. We have two pipelines, right? You know that, I just told you. So one of the pipelines, I both have a different task pointer, so I can just highlight this one, so highlight it. I can more easily see which is which. Can I get rid of this highlight here? Oh, that's weird. Oh, that highlight is I use the backslash, slash to search for it. I don't want to search for it anymore. Don't move that one. Or maybe I do. No, I don't. Just follow this task. So it's called calling reset. That is well, the very beginning of a task. We start with calling reset on it. And then the base state changes from reset to initialize. Then we run the base state initialize, which causes it to call initialize implementation, which you don't have, by the way. But the default sets to pipeline factory start, and it runs. Now the task starts running. It runs state pipeline factory start. We're not really interested in that until we get to initialized. Here it runs pipeline factory initialize without D. And here we start running pipeline factory initialized with a D. Now do not get confused by the green output. It's just another thread that's printing something. And you want to look at thread pool 3, which is white for some reason. So here you see that it is calling run. So this thing here should be our characteristic range. How many characteristics do we have? One, I think, only one. So this is the only characteristic that we have, and we call run on it, and it uses the immediate handler, which means that the thread that is calling run is going to execute it. Oh, 4 is an unknown condition. That's not good. Let's fix that before we go on. We can just quickly go back here anyway. Let's just search for condition equals 4 or something. There's a pipeline factory, I think, right? Oh. Not handle, pipeline factory. Yeah, all of these must be translated somewhere by debug code. Although I probably have all of them already, except these two new ones, characteristics initialized and filled. So where are those things? Let's search for that one. Not here. There it is. Okay, so we need to initialize. This one comes above that one and the fill too. I don't even think I implemented the condition string implementation for the new task. I was also missing from the documentation that I wrote. Okay, this one has as conditions. Jesus, this is a big one. Do fill. Guess it's also virtual function. Guess it is. Should be. It's called implementation. Yeah. Right. Okay. Copy this and then you switch to the other file and I put it below state string implementation or something. There. That's the only one that we had, right? Do fill. Yeah. Direct base class condition string implementation. So if we would have one that is not defined, and the direct base class of this characteristic range is AI stateful task, which is also defined, should be defined. I mean the direct base class. Yeah. So in fact we're calling then the AI stateful task condition string implementation. Which printed the unknown condition, because it was not one of these. Okay, I'm now going to run it again. Oh, by the way, I think I don't have... no, I don't have it. Thought I have another one where you can change the number of resource frames. So then you, if we would change it to 2, you would see that it just was flickering between 2 of them. I can, however, change also another... oh! What? It's broken. Okay, I can change the bottom. That works, thank God. The left position is broken. Oh, and I thought it works, but it isn't. And the top position? Top position works. Now it goes from 0 till, well, half, whatever. So I put it in the middle. Yeah, it's going from half. You put it like this. It's okay. So this one works, but the left position, the left is broken. I have to look at that as well. On this particular, on Vulkan, 2 years now. But yeah, let's do this first. To downside of less. Pipeline factory. Really, I just want to see when it starts running. Pipeline factory initialized. So there's one. Let's highlight. Let's not search for it. Let's just highlight that pointer, which is the pointer of the task. Oh, this is just set state. Running, here's it already starts running immediately. Running initialized, which then calls run. And now you can see what the condition is. See that before it said unknown, and now it says characteristics initialized. Although I'm not using it, I think. Not using it. Okay, so what happens then? Well, now the same thread that was running the pipeline factory, thread 1, which is the thread also that calls run, now starts executing that task. It calls reset, calls multiplex, runs reset, it runs initialize, it sets a state to initialize as being the first one that must be run, and it actually runs it, which then calls initialize, which calls initialize x1. Apparently this is pipeline 1. And that then is going to do a lot of things. I mean, we are initializing a pipeline. Mostly I think, yeah, generating shader declarations and then compiling the shader. So all the green stuff. Define the pipeline here, add uniform buffer, add texture. Now pre-process the shader code to find out which declarations we need. Prepare shader resource declarations, fill set index hints, int, yeah, random number, seed used, assigned score for combinations of shader resources. What is this? Thread pool 01. So scroll down until I get there again. That's not being run for a long time. I think the reason is that we're running the partitions algorithm here. It doesn't print anything, but which takes a long time. And I mean a long time. There it is. Prepare uniform buffer declaration. Prepare textile declaration. So this is the input code. Oh, well, I expect compiling it. Well, maybe it was already compiled like that. No, not possible. Maybe compiling comes later. Yeah, maybe it comes later. Okay, it's very possible. It's okay, so it got till a certain point, and now I think it just declared declarations already, but generated declarations and stuff. But anyway, now the initialize has finished, and therefore we send a signal. Characteristics initialized. And it's sending that to our highlighted pipeline factory task. The task is not waiting. That seems pretty unlikely. No, it's because it's not waiting because this is the thread. So this thread would be waiting if it had delegated all of the green stuff before to another thread. But we never got to the waiting part. We just called run and then immediately started running that task, the child task. So yes, this task, aka this thread, is not waiting yet, and therefore we queue it. Then it sets the state already to characteristic fill. Oh wait, this is the characteristic range task. So next we are going to fill. We're waiting for the signal do fill. No need to run. Removing from thread pool. But now we return to the pipeline factory. So the same thread, because this task no longer running. So we return from the run finally, and then we're going to wait. So it sets a state where it wants to continue, and then it waits for characterized initialized. But we already received the signal, so we don't wait, we just continue running immediately. So it continues immediately with the state that we just set. That then sets the state to multi-loop for, and then to multi-loop while, and then it does sends a signal do fill to the child task again. That's the same number as here. And because it's running in immediate mode, the same thread that calls signal is now going to run the child task again. So I can change that, so I can run it in the thread pool, and then yeah, the thread pool will pick it up, and this thread will just continue running after the signal. Anyway, so we call signal, which means that now this task is starting running again, and it's going to run the state fill. The fill is doing nothing, so it immediately finished, and it calls characteristics filled. I guess the reason that signal is being called must again on the pipeline factory must mean that the oh no, there is only, like I said, there's only one characteristic, so it's immediately also finished. So we call fill and then immediately call signal because it's the only characteristic that we have. And again, the same problem. This thread did not wait yet. It did not continue running the pipeline factory task. It went into signal and then started running this one. So by the time that this one is sending a signal, we are still not waiting. So this go on until we wait ourselves. That is the characteristic range's task is waiting. And then it doesn't run anymore, and then we return to the pipeline factory, which says we want to continue there, waits for characteristic filled, but that was already signal was already received, so we continue running with pipeline factory characteristics filled. Yeah, well, then we called initialize and fill both once. I think that's it. So then it just continues, and that's why it works. So of course this is an extremely simple execution, where we have only one characteristic range, and the pipelines are both independent of each other, so we just follow one of them, and then we're not even running that one child task in a separate thread. We just run it in the same thread that calls run and signal. So yeah, you could say we're burning a lot of CPU now, simply to call initialize and fill, which before we did that directly, and now we go through a lot of difficult task code in order to do the same thing. But the power of this is that now I'm using AI stateful task, which takes a lot of the threading out of my hands, and now I can make it extremely complex without losing functionality. Can make it very complex. At the moment it's just, basically doing nothing, just calling initialize and then calling fill. And fill isn't even doing anything. But it's a good thing to see anyway, that everything works out. The weights and the signals find each other, and they seem to be balanced as it were, and nothing is hanging or blocking or asserting or whatever. But yeah, we still have a problem left. I'm not going to continue with this until I know why my left coordinate is no longer working. That kind of sucks. Validation error. Ooh, another one. Another problem here. Oh boy. Shader input data and shader modules 0 and 1 have not been destroyed. Yeah. Well, the reason it's not been destroyed is because it's a unique shader module, so it would be destroyed if we just had destroyed shader modules. So apparently we did not destroy the shader input data object. Now why would my shader input data object not be destroyed? Yep, I know the answer. Okay, am I still a genius when I just see this and immediately know the answer? I hope so. At least sometimes I feel so stupid, and then I have moments like this. Alright, my brain is still working. The reason that this is not destroyed is because it's a member of the pipeline characteristic range, which I turned into a task. If the task is not destroyed, the shader input data is not destroyed. And the task is not destroyed because it's still running. And the reason it's still running is because I'm not aborting it. And that was the only reason, the only way to make the task stop. So there is missing code. In the factory, pipeline factory, after the initialized, no, actually after the field. Okay, let's go here. Initialized, fall through. Something is missing. What the hell? Where am I? Pipeline factory. Oh yeah. We run the tasks here. And then we always get here. This is the set state, so we always get here. Then we set the state to this, which means we always get here. And then either reinstate on multi-for loop, bottom multi-for loop. I guess this means that we reach the end of a for loop, so I guess we just keep running until we get here. And then we go to the bottom of the multi-loop for loop. We do next loop. If not finished, we continue. Otherwise, we set done. And then we come here. So in done, we must kill all the. We must kill all the fill tasks. That's pretty much at the bottom. Okay. The pipeline factory is already a pretty complex task, if you ask me. Loads of states, does a lot of difficult things. Yeah, no, it's not really clean to call abort, and there is a problem with it because I'm running. I'm just calling run here, right, on these things. And at the moment they finish, they would send me this signal here, but they never finish, which I'm totally fine with. However, this run is actually implemented like this with an on abort, and I did not pass that because there's a default thing here, abort parent. So if I call abort on them, they will say, okay, I'm gonna abort, but they will abort myself as well. And I don't want that. So I cannot abort them, or I should pass something else here. I can do signal parent or do nothing. If I could pass do nothing, then you just abort and then the parent continues running. But I wanted to use this because if in the future my child tasks are abort, then well, they just failed, and then I wanted the parent task to, I mean, parent task here as a pipeline factory is trying to create a pipeline, and then one of the characteristic tasks, subtasks says, yeah, sorry, but something went horribly wrong, cannot recover. Then the pipeline factory cannot create a pipeline. So I think that the most logical thing to do is on an actual abort is to abort the parent in this case. I mean, all hell will still break loose, but that's the only reasonable thing that you can do, certainly at this point. But I do not want my parent, I don't want to abort myself by calling abort on the child task. So I think that the child task should have a more clean way to exit. And we're not going to call abort on it. We're going to call signal on it. And I don't think I can know which signal abort up. I can wait on multiple signals. But once you start running, you just start running. So we'll just have to set some kind of boolean and then wake it up, I suppose. Yeah, so to do that, so we keep the abort parent thing here. But here I'm not going to call abort. Instead, I'm going to call signal. And that then must be a signal from the characteristics thing, which is a characteristic range, which has currently only one signal. I'm just adding another one. So better to use a different bit, otherwise it might confuse it with something, I don't know. It feels better. Just terminate here. But then, of course, we cannot just wait or do fill. You must be able to terminate it. Now we must call fill at least once. So I think I'm just going to wait for do fill here. And then no, not really actually. It's if I ever change it to run in not in the immediate mode, so it really is a different thread. then it would be possible that one of the child tasks is waiting here, and then another task fails, which would abort the parent, and then during the abort I want to abort the child, but without getting aborted myself again. So I just still want to just terminate. It means that we must be able to terminate characteristic ranges while they are waiting here as well. So just wait for either of those signals, and in both cases we would start running here. So I need to add here an if terminate, then we call yeah, can just call finish. So then I need a terminate boolean added to the characteristic range. I can call the signal from here, I suppose. Just terminate. Terminate is true, and then immediately call signal on the... Oops. Did I call it terminate? And I cannot call this terminate. Guess I'll call my signal do terminate. Just like the do fill. I don't know, now I've lost it again, you know. Just don't know what I changed. Or what I'm still missing rather. Thank God the compiler is helping me with that. If you make enough changes to your code, then you can just start compiling if you forgot what you still have to do. But it's more a tip for people who are 50 plus, I guess. If you, when I was young, I would not have to do that. I just knew. Invalid use of non-static member function. Terminate. Yeah, that was do terminate. No matching function for a call to vulkan pipeline characteristic signal. That's correct. Why did I not pass anything there yet? Because we're going to call terminate. Yep, and that worked. But if we are aborted, we also need to abort these things. So really, we want to do this from finish implementation. Do I have a finish implementation? Probably not. If if initial implementation and overview are added, then those must call synchronous task. Wow, what a good comment. Although it is probably not the class that we're talking about. No. Yeah, where are we? I think I just don't have it. So let's add it. Let me jump to I don't know what type those things have. Probably void finish implementation. Override. Yep. So this is called when you finish normally, but also when you are being aborted. And I want to do these 3 lines in both cases. So it's going to finish implementation. And now we're talking about aborting anyway. Do I not want to call this when we are aborted? Move new pipeline synchronously, set producer finished. Feels like I want to do that also when this thing is aborted. This is also a task. Cannot find it big. Set producer finished. Producer finished, store true. Send the signal to the base. Looks like the same kind of thing, right? In order to let the consumer continue, we must tell this thing that the producer finished. And I think that the boarding qualifiers is finished here. So let's move this one also here. Not that I will ever test it, but at some point you have to limit yourself. Get what I mean? When I have the really good feeling about, well, this is just correct, I'm not going to put an hour into testing because I just don't have the time for that. So this should fix the validation error at the end. Yep, no more validation error after program terminating. But if I change my left position, nothing ever works. Damn. Completely clean. What is a good way to attack that? Because that might have been already the case for a long time now. So what I want to do is run git k and then how about we do a bisect. I'm not sure how often I committed while it did not compile though. Let's go on 2, 3, 4, 5, 6, 7, 8. Nah. 11, 12, 13, 14, 15, 16. Cannot imagine that it didn't work here. I can test this one, I guess. Fictional uniform bar debug name. Ambivec debug names. Remove. Gonna go down even further, I think. Support for frame resources. Sorry, alignment. Let's skip the whips. Let's try this one. It's pretty far down. I need to paste that before I close this. Yeah, how does a bisect work? Git bisect start, I think, would be a good idea. You need to run this command from the top level of the working tree. Let me start with the help. So git help bisect. Starts. You can pass bad and good immediately. So maybe I should start with checking out and checking that or something. I don't know. We can just not pass anything and then do bad or good with revision. The only thing I know is that my current thing is bad. Why can I not pass? Oh, you can pass bad. Yeah, well, I don't know. Head is bad and no good yet. Bisect start head, maybe. Try that. Git bisect start head. Waiting for good commit, bad commit known. Yeah, well then we have to do a checkout, I think. Yeah, even this one's broken. See, bottom works, top position works. Well, now we have to go way, way more down. I'm merging uniform buffers in here. Hopefully can just do that and we go into here. That's too far down, I think. I don't know. Can just pick one, I guess. Make F4C work again. Probably UBT is still working then. I must have tested it. Cannot believe that it's that long broken. Let's try this one. Okay. Quit. Git checkout. Redefinition failed. timid. Yeah, that's a building cordon. Continue causes lost device. Yeah, well, I guess that. Not convinced that I remove this. Well, yeah, I don't know. Let's find where this was removed. Yeah, now I want to go up. I guess I'll just try somewhere halfway between the make FRC work again and the bed. So somewhere here maybe. Pretty random. Okay, so then we do quit and git checkout. And then we get the same error. That's strange. Maybe not that strange. I think this bisect is not updating or changing this git submodules. Should not really be a problem. Well, maybe I should just give up on this bisect because nothing compiles. Yes, I enjoy what I'm doing. I'm going to try this one. Git checkout. Compile. Compiling is the first step to running. Well, at least I committed mostly when it compiled. Ah! Please work. It works. Thank God. Then we can have a bisect takeover. Git bisect. Good. Bisecting to revision left test after. Roughly 2 steps. That's very fast. Very, 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 very fast. It still works. Just take bottom and top as well. Okay, that's also work. This is good. Bisect good. Undefined reference to right members to. Okay, let's try to fix it because I want to know if this one is good or not. So guess shadow builder declaration string .cxx is missing. Yeah. Source vulkan cm. Blink blink. Blink 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 blink. I'm not seeing shadow builder at all here. At all. Vulkan shader builder or something. It's a huge thing. That's not the moment that I added it. No way. Vulkan shader builder. Oh wait, shader builder has a CMake list text of its own. Nobody understands why. I'm so confused here. It's globbing it. Why didn't you say that immediately? I just have to run configure. Never use globbing for in CMake, guys. UBT. And the bottom works and the top works and left is broken. This one is bad. Get bisect bad. Yeah, I cannot test this one. You cannot test this one. It doesn't even generate the shaders correctly. Now I would like to though. Cannot fix the shader manually. Redefinition struct. Oh yeah, right, I see that. Yeah, too bad. Too bad. Get bisect. Skip. Yeah, now I left with two of them. That could be wrong. Okay, how big is this thing? Not big. Not big at all. Let's just look at it, I guess. Declarations. Declarations. Yes, I am. Unfortunately, I wish I was young again. I think I would pretty much do anything to be a certain age again. I won't reveal which age, but even if it meant to be poor in a different country. If your life is, if you're a big deal of your life is behind you, it's behind you, guys. It's really, you have just one life. I would always say any life is better than no life, but that's not exactly true, I guess. My life has been extremely suckage a lot of the time. I've been suicidal a lot, with reason. But in the end, it's always worth it. It's better to live and yeah. I don't know. Life's beautiful. I'm still saying that. Now, my parents now are 86, 85. I think 85. Not sure. And especially my mother. If you see how she has degraded, she can't walk anymore. She can't think anymore. She has no memory. She can't hold in her, you know, what do you call that? She goes to the bathroom too late, as it were. No control anymore. And it seems that most people have to go through that, unless you just, you know, die of a heart attack before your time, more or less. Fortunately, I have a strong heart, pretty convinced about that. So I think I'll have to go the sad way, kind of like my mother in the end. Yeah, the combination of having and I'm Alzheimer. That's I was saying. I'm gonna get that too because I can't remember it. Combination of having Alzheimer and getting lots of old age problems, you know, with your body. That's especially hard because she just doesn't know anymore how to fix things or solve things. Well, if you're getting so old that you have incontinency, you know, you can't hold your pee in. I don't know how to say that in neat words in English. But you're still right in your mind, then you find a solution, something. But you can't even do that. She doesn't understand most conversations anymore. So it's just, she's just vaguely aware of having turned into more an animal than anything else, and she cries a lot because she just realizes it. So yeah, how long do I have until I get like that? I don't know. At least 10 years, maybe 20. So then I'm at 3/4. And I definitely cannot continue coding like I did. All my bright days are behind me already, I think. I'm just going down, down, down. Sucks. It sucks. But, you know. I cannot give too much advice to people that are still young. Because I think I did most of the things wrong. I don't know. Well, I wasn't capable. My whole life I've suffered from panic attacks and stuff like that. So I felt always I could not do anything. If you're more stable, psychologically more stable, then I guess you could do weird things with your life when you're still young. Go on a holiday and go, I don't know, what is it, wing gliding or something like that, you know, or just, I don't know, visit the North Pole. Just do weird stuff and try to make memories or something like that. I didn't do too much. Plus, I cannot remember my youth. I cannot remember anything. Hardly anything, which also sucks. But I can code. Well, still anyway. I can still code. What will happen to me when I get some point and just cannot program anymore? That's the end of my life, because it's the only thing I can do and do. Literally nothing will be left if I cannot code anymore. Don't be jealous if you see how good I am at coding. Some people seem to be jealous, but it's not worth it. I think that I don't know, I'm just pretty open person anyway. I have no problems with telling personal things to begin with. I'm not sure I told this before, but I have been diagnosed with a form of autism. Originally it's called Asperger, but it's some high functioning thing. Sometimes I'm not sure if that's true. It's not simply related to having the panic attacks plus being an int J and high IQ. Those things combined might give the same, label. But I am high sensitive. I have never been able to stand the sounds and light and bright lines, and especially sounds are horrible. And I've not been very good socially. So I really lag behind in social development, and that's definitely an aspect of having autism, I think. But yes, I was very smart, so at some point I felt lonely. I mean, loneliness was something that, let's say you feel shitty and you have to do something with it. So I started to investigate that, and then I came to the conclusion that my shitty feeling basically was loneliness. And then I figured out, and this is not something I did in days or weeks, no, years, just at least a month, lots of thinking. So finally I came to the conclusion that was because of a lack of communication, that I lived in my own head, like people, especially children with autism do. They live in their own head. They only talk about their inner world. Their inner world is the thing. Is that the surroundings are not that important, and that was the case for me too. I was living in my own world, and it was very hard to communicate with other people about it, about what I experienced internally, and that made that made me lonely. So I think I was 18 when for the first time I finally understood. Oh, no, I skipped some part. So then I started to consider how to have social contacts with other people as my main problem. So I put all my IQ and analysis power behind that. I have done tests. I have done multiple tests, but one of the tests that I did was a test that it tested all kinds of how do you say, capabilities or I cannot find words anymore these days, or last years actually. Oh, you just have to do it with some other word. So I cannot. I was tested for a certain. what is a word? Damn it. Let's say abilities, whatever. One of the abilities that scored off the charts was analytic insight. So I did, another one was spatial insight, by the way. But okay, so I started to analyze social behavior. And that felt like the most difficult problem that I had faced before. Well, I was only 18, but still. I had done some crazy things in terms of abstract or mathematical-like problems, logic problems, computers, stuff like that. But social problems, my God, that was so difficult. Anyway, I think I was 18 when I, for the first time, realized how the brain worked. At least I had a model, made a model, where, you know, the memory, intuition, subconsciousness, emotions, and then especially how emotions did fit into, say, the whole picture in a way that could explain why other people did things they did. Before, I had no other picture of emotions and something that came out of your subconscious and you are aware of it. So you feel your emotions, but that's it. If you go to a doctor because you have panic attacks, they say you have to feel your emotions more. Well, so I feel, nothing changed. But I think I cannot remember anymore, I'm sorry. I had a picture of this, how the brain worked, and then suddenly I saw something like, oh wait, you know, if it is linked like, if it has a feedback like that makes sense. And I think that the big what is it? The result conclusion was that other people do choose what actions they take in order to optimize their own emotions. You know, say someone feels sad, then they do things such that they optimize that sadness away. Or if they are mad or some irrational feeling, some irrational emotional feeling, that's the main drive for those people. So, and since emotions are pretty much irrational in my eyes, that explained why so many people were acting irrational. Because they didn't think rationally about the problem, they just did whatever their emotions gave in. How to improve your emotions. I can very hard explain it. I can only give an example from that time. I think I even told it before on the stream. Now I think about it, I'm not sure. Around my when I was around 18, I was playing in a midget golf club, and I had won third prize. Now usually only males got in the first place and the second place. Women were just way weaker, sorry, but that's, I think, usually the case for certain sports. But yeah, now to buy, how do you call those things? Trophies. The trophies had a figure on top of it. So it was a beaker and then a midget golf playing a figure on top of it. And they just couldn't buy 3 male figures. So they bought, first prize was male, second prize was male, and the third prize was a female on top of it. So, and I got the third prize, so they gave me the trophy with the female on top of it, and the woman that had bought them gave it to me and said, well, yeah, there's a film on top of it. But if you bring it back next week, then I'll go to the store and change it for you. So I brought my trophy home and I showed it, and then I thought next week I would go back, and I saw that there was a what is it called, a wardle or something. You could just at the bottom you could just take the whole trophy apart and then end up with just a figure. I just saw it in front of me. In their shop they would have all the parts, and you could just choose, you know, I want that part, that bottom, and that bigger, and that figure, and that, you know, all those things. And then they would put it together for you. So why on earth would I take the whole trophy? Of course, I would just take the figure, and I would just put the figure back in the drawer and take a male figure out of the drawer. So that's pure logic. So I did that. And I came back to the Midget Golf Club and I gave that woman just a figure. And she exploded in madness. She was very mad at me. I had done something that was unthinkable. Now, it was, I think, decades later before I really understood her thought process. She felt that she would be looked at strangely, so she was ashamed to go back to the store with just a figure, because in her eyes that was not done. And that then turned into madness towards me, because I was the one who forced her to, you know, go in her underwear into the store and do this silly thing with just a figure. And she blamed me for that, and therefore she became mad at me, and she refused to do it. Actually, she said, "Take it back, and next week take the whole trophy." But she was really mad. I didn't understand that for so long, because, well, like I said, it's just bullshit, pure bullshit. What happened? I gave her the whole trophy, put together again. She takes the whole trophy to the shop. The shop owner does exactly the same thing as I did. He takes it apart, removes the figure, puts the figure in the drawer, takes a male figure out of the drawer, and puts the trophy back together. Why? Makes no sense whatsoever. People are idiots. And now I forgot, of course, why I started telling that story. Bramble Matt says, first time I've heard someone else describe my life. Well, we should become friends. I think the reason was that I said... I cannot remember anymore. Okay, what about the error here? Oh yeah, I'll look this diff over and I don't see anything except that it's a big... it has to do with declarations. Let's look at the other one. Oh, maybe I should have made a copy of it. What? Did I run it? No, I didn't. No, there it is. Let's make a copy of this indeed. These are the two that are bad, either one of them. I looked at that one, so now let's look at this one. Git show. Yeah, I remember something else that has to do with that. I just have to tell that. So I continue with analyzing social behavior, and I literally changed my personality with that. That problem was so huge that by the time I was done, and I thought I figured out how to socially behave myself correctly, I felt like I had a large part of my brain that before was used to be, solving mathematical kind of problems, so that made me a genius at the time, had been reallocated for social interaction. I just changed myself. I'm still weird in a way, but I've kind of cured myself from the worst autism ish things. I can now deal with loads of people even in a better way than most people. And for a very long time, I did everything purely rational. So my whole behavior, my whole social interaction, everything was calculated and rational. And then at some point, years and years and years and years later, I started to get so used to it that it became an automatism. And then eventually I forgot what the reasons was behind it, and I just changed into a normal person. More or less. Because even at that time, I think that, people always think about me as a weird person in real life after a while. And in the beginning, like when I just came living here in this house, I had contact with my neighbors, and the first impression is then, interesting guy, nice guy, and I can keep that up for now a month even, but eventually they start to think about me as a weird guy. Definitely. I'm just not exactly like those other people that live in the street here. And at some point, I had a little conversation. Just on the last thing that I will say, and then I'll continue looking at this. But really, two doors to the right here, I had a conversation with him. The last thing he told to me was, "Why don't you go back to Amsterdam? There you have more space." What kind of remark is that? I moved from Amsterdam to here. Why did you go back to Amsterdam? That's your neighbor saying that to you. And I was not calling him words or anything. I was just too autistic, too rational. I didn't like the reflections in the window of the car of my neighbor. The sun would shine into it, would shine directly into my eyes. I had to close my curtains. Okay, and they parked there because that guy was parking his car not in front of a window, but way to the left. So when I saw him in his car, I went there and I said, John, or whatever his name is, why are you parking your car so far to the left instead of right in front of your house? And he immediately went into full defense gear, as if he didn't like me from the start. Well, I'm parking here where I want, And then he had an argument that they didn't want to park in front of the small path between the hedge that was open there. But he was halfway. He was so far to the left that he was in front of that path. So it was the opposite reason. I said, why are you so much to the left? And he said, because I don't want to go too far to the left, basically. So I pointed that's all I did. I pointed to him out, but you are in front of the path. Look, it's 50 centimeters too far. And then he said, why are you doing this so difficult? I said, I'm not doing difficult. I'm just asking you a normal question. And then he said that, why don't you go back to Amsterdam? So I don't know. I didn't say anything anymore. I just turned my back to him and went inside. And then I think, is it me or is it the other? I used to think that it was always me, but I don't know. It's just maybe I think that people like that, they're just not rational enough. It's not that I'm too rational. He didn't like me. He didn't like it that I caught him on a stupidity, basically. Georgie. Yes, I'm still here. Hopefully for a long time. But I just promised that I was would concentrate on this diff again. I don't know, I have to quit. So go on from the top. This looks like the one that is causing it. Much more than the previous one. Struct bottom position is replaced by struct declaration. Member, float, etc. And then here we have left position. Left position called added is some struct. Unused 2. Also here. The mud 4 is unused. The float y is still there, but it has now become member 2. So we put this one in the middle. Well, if left position doesn't work anymore, that could be it, right? And some struct is defined as something that just one float. The only thing that bothers me is that I cannot believe that I would never test this. Top position also has some struct, but it's at the end. Well, okay, then we have an array, and I guess I'm not using the first index. So although I was playing with the top position, I'll put the top position as an array inside my uniform buffer. So we have a foo, and then we take index 2, and then complex, but top position still works and left position doesn't. Well, that is as simple as this, simply accessing y. Nothing changed here, just write to y. It could be that we never get here. Seems unlikely. So that this is never set. Well, that it is a change. So we could add the debug output here that to see that we are actually writing something to the uniform buffer. Most of the things I'm like, well, let's use the word the top and the bottom as well, and those work. So they can't be it. Thank God we are at the bottom. I might as well as it were have searched for left. I think I'm going to begin indeed with let's see. I forgot what I was doing, so I have to look at it again. Was something was created, or was it? We are writing here is created. Let's begin with adding that debug output, so that we know that at least it's being written to. In fact, let's print out what we are writing. I don't think that is that's the problem. So we are writing this value. They are writing it in the first place, and then I can also see that it changes. Yeah, that was not smart. I think I should check out master first. I just tested what did not stash it. Oh, push. Push. You cannot stash as one file? I guess you can't. Dash everything. Get check out master. Dash pop apply. What is it? Pop? Pretty sure that C does not stand for corporate. No, it's just, I think it's the next letter after B. I even think I ever saw YouTube about it, where it came from, but I cannot remember. Okay, it's running 0, and I'm changing the position now to -1, +1. So we're writing the right value. We are writing the right value, so it must be something else then. Let's get div. Let's remove this again. Then the other thing was DB's left position. It was a definite change that this thing was added in the middle. So what if I take that out? Yeah, that then it works again. So that was probably the reason why it stopped working at that point. But yeah, it should also work with. Yeah, let's look at the shader code that is resulting from this. Oh, really? Oh no, of course. So this is the declaration that we get here. And now we're using left position dot y. Well, that cannot be wrong. So we must have the offset wrong then. Oh no, well, not in this case. This works. Yeah, set 0, binding 0. Everything works. Let's add it back then. I have another one maybe. This is the one that we just looked at, I think so. And there is to position, and then we, oh yeah, there's some struct as well, yeah. What do you mean as well? Left position. Okay, so here's it 0, 1, and then no some struct. Is it? I think. So now the sum struct is here in the middle. Set 0, binding 0, still the same. Then some struct has been put in the middle. Now the struct itself just exists of a single float. What happens if I put a float here instead of a struct? And here's the other pipeline, which also doesn't work. Same thing. Again 0, 1, and then some structure. Left position. This is still left position dot y. I think John Doe, yeah, well, I don't really think that you should expect to understand it, even if you were Bjorn Stoestrup. You can know C++, but why would you understand what I'm doing? Then you would first have to study my project for a long time. Okay, test 1, I'm going to replace some struct, which is just a struct of a single float, with another float. So we're going to put here a float instead of a struct, but the size is the same thing. If that works, then the problem is the fact that it is a struct. This really should work. Scammers are not welcome. Okay, what we want to do here is run that thing again. Test that it now works, and it does. So yeah, the reason that it does not work is because it's a struct. I think that I think I really would like to know what the offset of y inside this struct is in the GLSL struct. Then we can check if that offset is the same in the C++ struct. And in other words, I want to know what the offset should be before we dive into the C++ code. That is damn difficult. And I have a test application somewhere. I think in Shader Builder that would be a logical place. Don't see it. I don't see it. Where would this be? What is it called? Maybe it's here. Yep, there it is. Well, I think it should not make a difference if I put no members in my test struct instead of directly inside the layout here. So it's already scary, but so it's somewhere in between the header and the footer, which is closest the test struct again. We have to write the right things. Array footer. Just an array. Tilt your head 45 degrees, Nightcrawler. And then you see pluses instead of X's. Huh? Yeah, I must say that what I really want to do is I don't understand this code anymore. It's a problem, of course. That is the problem. Let's do it manually. This is what I want to run. And it just writes normally just some type, some variable, and then a boolean at the end to get the offset. But I want the offset of my float, and you can just fill it in, I guess. So I really want to have test struct, this stuff, copy, and then I don't know how to call that. Let's call it troop.glsl. Static footer. So that's a footer. And then we do not need these, and we need these, and we don't need this. And then I want here to have mod 4. Oh boy. Top. Let's begin with float as the test case. Maybe I want to do what I do in the real program. I'm just putting it here. Might as well try that. Oh, but in the end I'm gonna need that. Undo. It's called sum struct with a float in it. So now we have a float, and then later we're going to replace this with sum struct and then see if the offset of y changes or not. I would think it does not. It should not change, right? That's the output. Now we have to find back what the offset is. Here's my y. Op member name 2. Maybe this one. 68. Seems so. Yeah. Matrix stride 16. This is a 4 times 4 matrix, which is seen as an array of 4 vectors. Then I guess this is the stride of one vector. Well, one vector happens to be 4 floats. The float is 4 binds, so that would make sense. So it's even packed then. Times 4 is 16 times 4 is 64, though the offset of unused 2 is 4. And add 4 to that for this float, and then y sits as at an offset of 68. What else can it be? That means that if I add a second float here, then my y becomes a float of 72. And it is 3y3 offset 72. Now we're going to replace this thing with some struct. I don't know what its name was. 80. Y is 2, 80. Holy moly. So big a number I cannot even calculate from my head. 80 minus 64. 16. Okay. So that definitely did make a big difference. The struct takes 16 bytes at least. Well, for a standard 450. What the hell is that? For 100, sorry, that's 4.5. 140 is what we're using, and that has the tendency to round up things to 16. So I guess that's correct. Now I wrote somewhere down rules for this. Can we find back that the size of a struct for standard 140 is at least 16? We have a readme descriptors, is that it? Nope. Or maybe to the bottom here. It just isn't. Okay. Another readme here. Nope, also not. Then we have a possibility that I have no clue where it is. Resources. Nah, something else. Textures. Also not. What did I put that? Put it somewhere. I guess I put it in Vulkan somewhere. Of course I put it in Vulkan somewhere. How about shader builder anyway? Readme shader memory layout. That's the one that I was looking for. Struct. The size of a struct is equal to the offset of its last member, that's 0 in this case, plus the size of its last member, which is 4, rounded up to the nearest multiple of the alignment of the struct. The alignment of a struct is equal to the largest alignment of each of its members. Apparently not. Or no, I don't think so. So here you have a special case. The alignment of an array is equal to the alignment of one of its elements, even if the array size is larger. And for SCD 140 rounded up to 16. Apparently that's also the case for the alignment of a struct. Doesn't say here, but it sure feels like it. Damn. Another mistake. is the alignment of a struct rounded up to 16? We can test that. That's the one that we were in. Now I have to go back to where we were. Or not. Yeah. Let's edit this file again. So this has a size of huge. I want to know the alignment of the struct. So it is replace this with a boolean, and this gets an offset of 16. Then definitely that's the alignment of the struct. Yep, 16. So it's really the alignment. The alignment of a struct gets increased. What happens if we do is it 430 or what is the other one? I don't know. Yep, 430. Okay, 430, this is nothing, just 4 and 8. So the alignment is not rounded up. I think it's really a thing of the 140. So then I would have to change. Cannot find it back anymore. This is just a guess, but it seems like it. Maybe shouldn't be guessing, but I think it's a pretty damn good guess. Now the problem is, where do I find this in my code? Oh my god. Okay. Good guess, it is something with alignment. Wait, worse, not just alignment, alignment X. I meant, well, like this. So, we have array alignment. Could it be struct alignment? Nah. I think I need a function like. Oh, it's almost nothing. You can just read it. What is this? Oh, that's actually not unlikely that it is literally saying it. The alignment of a struct. I'm going to search for that. The text happens. Yeah, alignment of an array, alignment of a matrix. Doesn't even talk about alignment of a struct. Okay, what about alignment and struct on the same line? Max alignment, because it was equal to the alignment of the largest alignment of one of its members, right? So that would be stored in max alignment, and then we have to round that up. So I'm gonna have to search for max alignment, I think. Oh, they still fail a lot, but this is just template parameters. Not really using it. And then suddenly we have max alignment. Really? That looks like what we are looking for. Max alignment, and then it is being the maximum of the previous memo layout and the current one, I guess. Well, anyway, it's something to do with memo layouts. Max alignment. Yeah, alignment is the last memo layout max alignment. That is the line that we end up with. Okay, so we have a struct layout alignment. This is the alignment of the struct. And currently it's not rounded up. Now, so we can fix this if we know the standard here. And we do know the standard. Standard is here. Standard. So yeah, there's a different thing here, but okay, the idea is the same. The race stride is rounded up. If it is STD 140, we must take it the max of the 16 and that, and otherwise that thing. So this line, we need this line, but then a little bit changed. And then we need it for alignment, right? Which is the only thing we changed. The alignment of a struct is yeah, just standard, I guess. The standard, if that is that, then the max of last member max alignment, and 16, otherwise just the last member alignment. No, I want to go here, of course. Yeah, I'm just going to compile this and see if it works with the float, and then we're going to go to the sum struct again. And then I'm going to do something else because it's 11 o'clock. It works. I know it works. UBT left. So that worked. And then we go to this line and we use some struct. And that should bump the alignment of the struct to a multiple of 16 and blah blah blah, and then everything just works. Just works. No problem. So good night everyone. This is the end of the stream. No, seriously, it's just fixed. Look, left, up, fixed. How beautiful is C++? But I'm serious. Good night everyone. Thank you for being here, and I'll see you tomorrow, maybe.